students. Today is the first lecture of kinematics and theory of machines. So unit 1 is definitions and basic concepts. So topic of the first lecture is introduction to machines. So first question comes, what is a machine? Okay, so a machine is a device which receives energy in some available form and utilizes it to do some particular type of work. Or a machine can be defined or may be regarded as an agent for transmitting or modifying energy. So everything that relates to energy depends on machine. Okay, so next, the machine. A machine is a combination of components which can transmit power in a controlled manner and which is capable of performing useful work. A machine consists of a number of kinematically related links. Next point. A machine is a combination of resistant bodies, that is, links or elements, which we will discuss in the coming lectures of this subject. With successfully constrained relative motions, which is used for transmitting other forms of energy into mechanical energy, or transmitting and modifying available energy to do some particular kind of work. Okay, so let's have a look. This is the table you have seen, where you have seen this input and machine and output. Okay, so if you give input like mechanical, electrical, hydraulic, chemical or nuclear, then machine will be kinematic arrangement of links like rigid hydraulic, rigid pneumatic, and output energy will be mechanical, maybe electrical, maybe hydraulic or thermal. Okay. Next, if we give input as force, velocity, energy or time, power, a machine has moving parts which must be constrained and controlled. So output will be force, velocity, energy or time, power, which is same as the input. Next, machine arrangement. Every machine will be found to consist of a system of parts, that is links or elements. As I have already told that links and elements will be discussed in the coming lectures. Connected together in such a manner that if one be made to move, they all receive a motion, the relation of which to that of the first depends upon the nature of connection, that is joint. The links may be rigid hydraulic or rigid pneumatic. The power input may be mechanical, electrical, hydraulic, chemical or nuclear. The power output may be mechanical, electrical, hydraulic or maybe thermal. Okay, so here are some of the examples of machines. First is the heat engine. Heat engine receives heat energy and transforms it into mechanical energy. Next, electric motor. If we look at electric motor changes electric energy into mechanical energy. Okay, pump. In a pump, input electrical power and output hydraulic power. Okay. So moving on to the next slide. The majority of machines receives mechanical energy and modify it so that the energy can be used for doing some specific tasks, or for which it is designed. Common examples of such machines being forged, lathes, screwjet, etc. These machines we have already seen in the workshop. If not, I will show you later. Note. It should be noted that machine must be capable of doing useful work. A series of kinematically related links put into motion with no output link and which simply converts input energy to friction heat is not a machine unless the original purpose was only to generate heat. Next, we move on to classification of machines. So, number 1 is machines for generating mechanical energy that convert other forms of energy into mechanical energy. Examples of this type of classification of machine is steam engines, steam turbines, IC engines, gas turbines, water turbines, etc. Number 2, machines for transmitting mechanical energy into other form of energy, known as converting machines. Examples: electric generators, air or pump, hydraulic pumps, etc. Okay. Number 3 is machines for utilizing mechanical energy in the performance of useful work. Example: lathes and other machine tools, etc. The transmission and modification of energy within the machine require the inclusion of a number of parts, that is links or elements, which are also selected that they will produce the desired motion and carry with safety the forces to which they are subjected so that the machine can perform its task successfully. Okay. Next, the study of relative motion between the various parts of a machine and the forces which act on them is covered under the field of theory of machines, or the theory of machines may be defined as that branch of engineering science which deals with the study of relative motion between various elements of a machine and the forces which act on them. So, this particular course or this particular subject of theory of machines that which we are going to learn is a branch of engineering which deals with the study of what? Relative motion of various elements. A machine consists of various elements. Okay, so in this course we are going to learn about the relative motions of the elements of a machine. Okay. Now, what is the difference between machine and mechanism? Machine and mechanism both are different terms. Okay, so here it goes. In kinematics, a mechanism is a means of transmitting, controlling, or constraining relative movement. The central theme for mechanisms is rigid bodies connected together by joints. It can also be defined as a combination of resistant bodies that are shaped and connected in such a way that they move with definite relative motion with respect to each other. Okay. Whereas a machine is a combination of rigid or resistant bodies formed and connected in such a way that they move with definite relative motion with each other and transmit force also. Okay. A machine has two functions: transmitting definite relative motion and transmitting force. So these two functions are very important for a machine. A machine does what? Transmits definite relative motion and also force. They transmit both of them. Okay. The term mechanism is applied to the combination of geometrical bodies which constitute a machine or part of a machine. So here are the differences between machine and mechanism. It is a combination of links having relative motion and has the capability of modifying available energy in a suitable form, whereas a mechanism is a single system to transfer motion. A machine can consist of one or more than one mechanism. Example: lathe machine has several mechanisms. Its objective is to transmit mechanical energy, whereas in mechanism, its objective is to transmit motion only. It is a combination of links which transmit and transform its motion only. Example: a simple example of machine and mechanism is IC and slide diaphragm mechanism. A slide diaphragm mechanism converts rotary motion of crank into sliding motion of slider, whereas in the IC engine, the same mechanism is used to convert available mechanical energy at the piston into the required torque and the brakes. When you go in details to this course, we will come to learn about slide diaphragm mechanism, which I am going to teach you in the future lectures. Okay, so no need to worry about it right now. Okay, next, kinetic analysis of mechanism. Various mechanisms have its own set of outputs when they are put in motion. The analysis of the mechanism is done by calculating the position, velocity and analysis of motion of a particular mechanism, we don't need to consider the cross-section area or strength of the part in that mechanism. Also, it does not matter whether the parts are made of cast iron or wood or anything else. We should study in motion analysis. Okay? Next, synthesis of design. In the design of a mechanism, we will consider stress analysis and other design parameters like bending, netting, etc. to find the dimensions of the parts. Okay. The synthesis of a mechanism can be done by following two approaches. First, in the first approach, the dimensions of the parts in a mechanism is found by considering load, stress and bending, etc. in the different parts of the mechanism. In the second approach, the dimensions of the parts are assumed first and then the analysis is done to check its strength. The second method of synthesis is preferred by most of the engineers and it is a preferable one. Okay. Next, kinematics of mechanism. It involves the study of the relative motions of various parts of the mechanism without considering the forces producing the motion in the parts. It is the study from the geometric point of view by which we can know the displacement, velocity and acceleration at the various points on the parts of a mechanism. Next, dynamics of mechanism. It involves the calculation of forces impressed upon various parts of a mechanism. The forces impressed on a mechanism can be divided into statics and kinetics. I guess statics and kinetics we have gone through engineering mechanics in your previous semesters. Okay? Okay. So what is statics? In statics, the study of forces is done when all the parts of the mechanisms are in equilibrium. Okay? Where in kinetics, the study of inertial forces are done which may occur due to the combination of mass and motion of the parts. Okay? So with this, I would like to conclude lecture 1 of today. So let's meet on